In this video you will learn what is NgRx signals, how to use this library, and what is the pros and cons of it. And the sponsor of this video is UploadCare. If you want to make possible files uploading on your website, you typically need to build frontend, backend, storing files on either your server or uploading them to CDN. And it's a lot of work. If you want to implement upload directly from Google Drive or Dropbox, it's even more work. UploadCare solves all these problems at once, and just in several lines of code, you can get all these things out of the box. If you want to check UploadCare, there is a link in the description box below. Not so long ago, inside NgRx 17, we got a new library which is called NgRx Signals. And it might be really confusing what it means, because we have something like NgRx State, which is a global NgRx, we also have component store, and now we have NgRx Signals, and you might think, okay, NgRx Signals is a full replacement of NgRx but with signals. This is not true at all. NgRx, its state, reducers and effects all are working just like previously. And yes, sure, you can transform quite easily NgRx stream from the selector to the signal, but it is not related to NgRx Signals library. NgRx Signals library is a completely additional library which is not related to NgRx State at all. You can just think of it like a separate library in NgRx family. And the goal of this library is to simplify for us working with Angular signals. So it is not about NgRx at all, we are talking here only about Angular signals and how to simplify working with them. And here on the official website on the left you can see NgRx signals, and these are the key principles. And most importantly, you can see that NgRx signals is a standalone library which provides a reactive state management solution and a set of utilities for Angular signals. It should be declarative, simple, modular, extensive, and so on, and obviously type safe. And our first step here is to install this library. This is by npm install NgRx Signals. As you can see inside our package.json, we are getting NgRx signals, but not NgRx, effects, or all standard stuff that we are typically using. This is a completely isolated library, which is working just with signals. And here inside I already prepared for us some files, so inside source app posts I have an interface for the post which is just ID and title, and I have a service post service where inside we have a method getPosts, and it simply returns the array of our mocked posts with delay of 2 seconds. Additionally, here I have a post component with just a form where we can add a post, but nothing is binded here yet. And here is our empty component. We simply injected here a service, we created a form, but nothing else. And just imagine that this is our post component where we want to render a list of our posts, then maybe an error message or loading indicator, and also a possibility to remove our posts. If we are doing that with signals, we typically will create several signals just inside our component, like signal for the post, signal for an error, and signal for a loading. Inside NgRx signals, the idea is that we simplify this logic and make it more declarative. This is why here what I want to do, I want to create a state. And here we can call signal state, and as you can see this is a function from NgRx signals, and inside we can provide our initial state. It is an object with, for example, posts empty array, then error is null, and this loading is false. And you might say, okay, this is looking really like an initial state inside an NgRx reducer. And this is exactly the idea. Here you can see on the glance the whole state that we will use inside this component. It is not splitted in different properties, it is all in one place. But obviously, in order to use it correctly, we must cover it with the interface. This is why here let's create an interface, and it will be post state interface. And we want to say that inside we can have posts, which is a post interface array, also is loading, which is a boolean, and the last one is an error, which is either string or null. And now here inside our signal state, we can provide our post state interface. And in this case, inside our state, we are getting a completely correct signal state with correct data. Now let's update our markup by using this state. We can jump inside our HTML, and after our form we can create, for example, one more div with loading, and we're rendering this loading only when our property inside our state is in true. So here will be state.isLoading with round brackets, because this is actually a signal. And exactly the same we can do with error. So if we have state.error, then inside we can render state.error with round brackets. And last but not least, we want to render our list with the post. So ng4, and here we have our post of posts, and this post we have also inside state. So it will be state posts with round brackets, and we must close a div here. And inside let's render a post.title. Also, as you can see here inside form, I have onAdd function that we also must create. And this is why I want to jump inside TS file and simply create this empty function. As you can see in console, we don't have any errors. Let's jump to the browser. We can see our form here. We obviously can type something, but our post is not there because our array is empty. And in order to add a post, we must implement this function. For example, here let's create our new post, which will be our post interface, and we must provide here an ID and title. And for ID we can use crypto.randomuid, and for title we can use the value from the form. It is this at form getRowValue, and here we are getting our title. And what we want to update now is the list of our posts inside the state. This is why here let's create updated posts. And this is just an array where we're spreading our this state.posts with round brackets to read a value, comma, new post. So now here we generated our array of updated posts, and we can use patchState function in order to update our state. So it will be this state. And here as a second parameter, we're getting access to our state, and we must return the new state. This is why here we can spread the whole state, and then we simply update posts to our updated posts. Which actually means the only way to update our state is by using patchState method, which we are calling on our specific state, and we are getting access of the previous value, and we must return the new value, and it must be fully immutable. And this is really what I like about NgRx signals so much. They really leverage immutability, functional approach, and declarative style of writing code. Which actually means, for example, inside signals previously, we get a mutate method, which allows us to mutate existing data without returning new data. And yes, this method was removed from the signals inside Angular 17, but it is not a best approach. This is why here inside NgRx, we're getting a really nice API on top of the signals to use them in a better way. We structure our state in a single place, we don't have signals all over the place, and we have just a single way to update the state. And the last thing that I want to do here is reset our form. This is why here this add form and then reset. Let's check if it's working. I'm reloading here the page, I am typing something, and as you can see our data appear on the screen. Which actually means what's happening, we have here the state, it is rendered inside our HTML, there are signals inside the state, and now we're using patchState to update our state by returning new data. Now let's say that additionally we want to implement removing of single post. This is why here let's jump to HTML and create here a span inside our loop with cross, and here we want a click event which we'll call remove post. And we must provide inside our post.id. Now here let's create a function removePost and provide inside an ID which we want to remove. And first of all here we want to generate our updated post by filtering this post out. So it will be this state post, so we're reading our posts, and then we want to filter them, and we just check that our post ID should not equal an ID that we provide. And after this we can do exactly the same line with patchState, where we're updating our posts with new data. Let's have a look. Here we can type some data. I'm clicking here on the cross, and our element was successfully removed. Realistically, I would say that this approach with signal state covers like 60 or 70% of most popular cases. You don't really need something more complex for your components, you simply want a way to structure your signals. But if you want something more complex and maybe you want to move this logic outside of your component, then you can certainly do that. This is why I want to comment out completely our state on add and remove post, because now we want to write all this logic outside of our component. And what I want to do here, I want to create a new property which will be post store. And here I want to call not signal state, but signal store. And it is a more advanced way, which is more flexible and has more features. This is why what we're providing inside as a first parameter is with state. And inside with state, we must provide our state. And just to remind you, previously we had these three properties inside. Let's just move it inside the state. But it is not all, we also must provide here our interface, which is our post state interface. Essentially, this is the same stuff like we wrote here inside. But here is a twist, we must register it inside our providers in the component. So here will be post store. Now we can jump inside our HTML and change everything. Our state is loading, error and post to store. And the store property we will get inside in a second. So in order to access this store inside our TypeScript, we can just inject it here. So our store will be inject of post store that we just created. And now we have full access to it inside our HTML and inside our component. So we just used inside with state, but there are more features to that. We can use here withComputed, and inside we can create all our computed properties for this component. So here we're getting access to the full store, and we must return an object with some computed properties. For example, let's create here a property post count, and here we're just calling computed as a value, and inside we're providing a function where we can write store dot, and as you can see we're getting full access to our posts. We can read them here dot length. So with this code we successfully created for us a computed property post count, which is now available inside our HTML. So I can open our HTML file, and here on the top let's create one more div and write inside total, and then here will be store.postCount with round brackets. So this is how we can render computed properties and create them just with the help of withComputed. But what about our add and remove methods? Previously we simply wrote them inside our component, but now this is a business logic because we are talking here about our state and we can move all this logic outside. This is why here we can create withMethods, and inside we are getting access to our store, and we must return here an object with some properties. For example, here will be add post, and we know that we want to get inside a title, and this must be a string. Now what I want to do, I want to copy the whole logic of onAdd inside. So what we want to do here, we want to create a new post. This is totally fine, and we're getting title from the parameter and not just from the form. Now our state does not know anything about form at all, so we can remove this at form reset, and now the only question is how to update our state. And again, we want to get our updated post by reading our store post because we have accessed it from the first parameter, and after this we want to update our state. And here we previously used patch state, this is totally fine, but here as a first parameter we are providing our store. And here as a second parameter we can omit all this code and simply write an object post equal updated post, and it will merge all properties correctly. But as you can see here I made a typo because we must spread all our posts in order to pass them inside. So essentially the code is the same, but now it is completely isolated outside of our component and we can easier test it. And the next thing that we want to create is additional method remove post, where inside we're providing an ID and it's a string. We can also move our code from remove post inside this method and uncomment it. So here we're changing this state post to this store post. And now here instead of the second parameter we can just update our post to updated post just like we did previously. And it is not this state, but it is store. And also here we don't need our this. As you can see there are no errors. Let's check here. We're getting an error that remove post does not exist inside our post component, which is completely valid because inside our HTML we commented out on add function and remove post function. So what we can do with our remove post, we can simply call here store.removePost, because all our logic is just a business logic. We don't have any component logic inside. But we can't really do that with onAdd, because inside our onAdd, as you can see here, we are doing resetting of our form. But what we can do instead of all this code, we can remove everything and simply call here this store add post. And as you can see, this is a function where inside we must provide our title. And it will be this add form dot get row value. And here will be dot title. And with this single line, we're updating our business logic inside state. And with this line, we're resetting our form. As you can see here, everything is green. Let's check this out. Here I'm typing something and we can see our elements. First of all, we can see that our computed property is working and all our logic is working just like before. We can add and remove our posts. So essentially, withComputed and withMethods allows us to write business logic in a structured way. And now as the last step, let's do something more complicated here. Let's say that we want to load some data on initialize and render them. And essentially, even with this approach, it is completely normal to write implements on init. And inside your NgRx that you will create here, you can simply call your service like this post service get post.subscribe. You are getting our posts from the backend. And then inside we can call some method to provide posts inside our function. For example, here on the top, we can create one more function, add posts, where inside we're throwing a list of posts. It's our post interface array. And inside we can simply patch state of our state, and we're updating only property posts. This is totally normal, but here it's not a state, it's a store. This code is totally normal. This is just a plain method to update our state, and we can call it inside subscribe. So it will be this.store.addPosts. And inside we are providing our posts from the backend. Let's open our browser and reload the page. As you can see, after 2 seconds, we got our list of posts from the backend. This code is extremely easy. You can leave it like this, and I actually prefer to write code in this way. But we can do it differently. I will comment out our NgRx and we can write this whole code inside our store. So what I want to do here, I want to build a method which is called load posts. And this is a method which will use a stream from our service. And in order to get access to our service inside withMethods, we can provide a second parameter which will be post service equals inject, and inside we're injecting our post service. In this case, we're getting full access to our service in any method. Now here what I want to call is a rx method, and this is a function, and inside we're saying that we don't want to return anything, it simply must call some method. And what it allows us to do is to write a stream of data. This is why here inside we can write a pipe, and inside we can pack a switch map, which actually is super similar to effects that we're writing inside NgRx. And inside our switch map we can simply return our post service dot get posts. On it we can call our pipe again with tab, for example, and tab means that we want to do something, and what we want to do is exactly like previously, patch state, and we're patching our store with updated posts that we got from the backend. And actually here inside our tab we're getting access to our posts, which actually means this is an NgRx way to get some data from the API call. Now we have this load post method and we can actually use it inside NgRx, for example. This is totally normal. You simply move the logic to your store, but we can do it even differently. After our withMethods, we can create also some hooks, and we have here withHooks, and inside we can provide an object with hooks. And there are just 2 hooks on init and on destroy, and essentially they are being called on initialize of our store or on destroying of our store. And inside on init, we're getting access to our store, and here we can call some methods, for example, store.loadPosts that we just created. So essentially this code will call this method, and this is our method which will fill our state. So essentially every single time when you are providing the store here and you are injecting it inside the component, then it will be initialized and it will load our data. This is why when I reload the page, we're getting this data automatically without NgRx, and they are filled inside our state. And now later we can use this store and some method to work with them efficiently. So as you can see, NgRx Signals is an amazing library, but if for some reason you are missing the knowledge how signals are working inside Angular, make sure to check this video also.